Welcome to the notes on perpendicular and angle bisectors. We're going to get right into it. First is the perpendicular angle bisector theorem. Okay, right here, perpendicular bisector theorem. And it says if you have a segment, all right, and PM is perpendicular to AB, all right, you can see our little right angle symbol right there. And if this distance from MA to MB is equal, well, then we know that any point on this segment, all right, is going to be equidistant. And that's what this word right here, equidistant, means equidistant from the endpoint. So this point right here, P, is on the bisector. Well, any segment you draw to the endpoints will be equidistant. And then there's the converse. Remember, that's just flipping the if and the then. If you've got a segment where it has equal distance, PA is equal to PB, well, then if I draw a perpendicular line, it will then bisect this segment down at the bottom. So these pieces will be equal. So again, if it points out a perpendicular bisector, it's equidistant to the endpoints. So how are we going to use that information? Here's a quick example. Find the length of QR. Well, first, where is QR? Well, here's QR, okay? And here is a segment, a perpendicular bisector where it forms that 90, and it bisects that segment. Well, then, since that's the case, I know that these two segments must be equal. So I'm going to simply set them equal to each other. So 6y minus 2 equals 8y minus 10. Okay, now it's an algebra problem. Solve for y. Well, I'm going to subtract 8y, subtract 8y. So I'm going to be left with 6 minus 8y is negative 2y. Oops, change colors here for it. Negative 2y minus 2 equals negative 10. I'm going to add 2. So I'll be left with negative 2y equals negative 10 plus 2 is negative 8. Divide each side by negative 2. So my final answer will then be y equals, scroll down here, y equals, good, let's change those colors for you. Y equals negative divided by negative is positive, so that's y equals 4. Am I done? No, I need to find the length of QR. So I then need to plug this in to this equation to find QR. So I'm going to simply say 8 times y. Well, we now know that y is 4. So I'm going to plug that 4 in there, and then I'm going to subtract 10. 8 times 4, that's 32, minus 10. So QR is going to equal 22, and that is my final answer. So there you have perpendicular bisector. Now let's go on to angle bisector. Again, angle bisector, what does that mean? Well, it means it cuts the angle in half. So it says, if ray QS bisects angle PQR, so here's PQR, here's the bisect, all right? And if you have two segments, SP is perpendicular to QP, and SR is perpendicular to QR. And you can see that right here. So here's SR, perpendicular to QR, and here's SP, perpendicular to QP. Well, then these segments right here will be equidistant. Pretty simple. And then again, here's this switching. If you have these perpendicular segments that are equidistant, well, then you know that you're going to, if you draw a segment QS, it'll bisect those angles. How are we going to use this information? Here's a problem. Now we're going to find the length of FB right here. Well, here's our angle bisector. You can see it's an angle bisector, and you can see that we have these perpendicular segments here. Well, then we know that these are equal to each other. So once again, we're going to set this equal to that. So here we go, 6x plus 3 equals 4x plus 9. Algebra, subtract 4x, subtract 4x. So you'll be left with 2x plus 3 equals 9. Let's subtract that 3. Subtract that 3. So we're going to have 2x equals 6. And then we know to divide by 2. Divide by 2. X equals 3. Am I done? No, we need to find FB. Well, where's FB? It's this one right here. You can plug it into either since we know they're going to be the same, but let's plug it right into FB. So we're going to say, hey, 6 times x. Well, we now know x is 3. All right, and then we're going to add our 3. So 6 times 3 is 18. 18 plus 3. So there we go. So our final answer then will be FB equals 21. And there you have your angle bisector and perpendicular bisector theorems.